Okay, we're live. Go ahead and take it away, Rachel.
Hello, everyone. Welcome to the April edition of the Audio Programmer Meetup. Thank you for joining us today. We really appreciate you taking the time to come and hang out with us. My name is Rachel Locke. I co-host this meetup on the second Tuesday of every month with my good friend Joshua Hodge. And each month we invite some guests to come and enlighten us on topics relating to audio programming. I'd like to remind everyone that our submissions are open for talks for the meetup, and those talks don't have to be particularly polished, and you don't have to be particularly experienced in giving talks or in the industry to come and give a talk. We like to keep a diversity of talks, whether it's a project you're working on, some research you're doing, whether you're a student up to a CEO. We'd love to hear from you if you've got a topic of interest. And the link to submit your talk will be down in the description box underneath the video. Before we get started on introducing our guests for today, I'd like to quickly thank our sponsors. They are Juice, Sonox, and Focusrite. Thank you so much for your continued support and allowing us to make this meetup happen each month. I'll now pass over to Josh, who's going to introduce our wonderful guests for today.
Yes, thank you very much, Rachel. And yeah, welcome to everybody. And before we start our first talk, I'd just like to remind you about our Discord community. So we have over 7,000 people from all levels of experience in audio programming, all different backgrounds. And we invite you to join us in our community. It's a very vibrant community, and we love to take pride in the fact that we're very welcoming to anybody, no matter where you may be in your audio programming journey. And you can join us at theaudioprogrammer.com/Discord. So you can join us there. And with that, we will launch into our first talk. And we have Alex Grieco from Audinate, who is going to be giving a presentation on the Dante Application Library. And take it away, Alex. And while Alex is getting set up, I will just remind you, if you have questions, please feel free to submit those in the chat, and also, and we'll ask them after the talk. And just to help me see them, be sure to preface them with question, and the word question in all caps. So yes, please go ahead, Alex.
Great. Thanks, Josh. Can everyone hear me? Is that?
Yes, all good.
All right, great. Thanks. I'm Alex Grieco with Audinate. And today we're going to talk about building an AV over IP ecosystem, and subtitled this presentation, Dante Everywhere equals Dante Anywhere. And that's really our focus in expanding the Dante universe and Dante ecosystem. So we'll talk about a couple of options and maybe potential for you to integrate in your products, in your applications. So as I said, my name is Alex Grieco. My role is account manager at Audinate, and I work exclusively with audio software developers, really trying to build those partnerships and relationships. We have a strong set of colleagues that I work with that maintain our relationships with hardware manufacturers or OEMs, where we've built a strong relationship. Before we get into any of the technical details and more of the Audinate products, I wanted to share a little bit about my own signal chain. Share here, I'm using a Shure SM58 mic, rock solid, going through an Avitran breakout box. This is a Dante device that, as you can see here in the image, it has network ports and audio connections. So I've plugged the microphone in, and the output going to my headphones comes all through that box. But that actually connects to my router in my home network here. Certainly in a larger environment, you have more robust equipment. But that router then provides connection to my laptops on the network. So as I'm connected to Zoom here, the audio from the microphone goes through the box, gets mixed for my headphones, my loop back or my own feedback, could go to the second machine for recording or a separate broadcast, and then go through my primary machine for this event. So just to paint the picture, there's what we're looking at here with Dante and Audinate is really taking audio and video and putting it on the network. So we'll dig into that a little deeper and talk about what is Dante and who is Audinate, the company that makes Dante. We'll talk about links to a computer. We'll talk about software solutions that we have in the market and you may have used already, and use cases and benefits of implementing Dante in your devices and applications. We'll certainly have time for questions as well. So let's jump right in. So to give you a little bit of background about the company, Audinate was formed in Australia, headquartered in Australia, and really started by network engineers with the goal of serving the audio video industry. And the goal, the objective was to develop a fully interoperable solution for manufacturers, so not proprietary and not limited to a single type of device or type of implementation. And as we click through here, you can see there's an example of a live event where you may encounter existing Dante devices where the mixing board, for example, or inputs on a stage, preamps and inputs on the stage are all networked. And by connecting all of those devices, now you have the ability to route the audio and video from anywhere to anywhere within this environment. And on top of that, you have the ability to manage the timing and synchronization between these devices. So playing out video to multiple screens becomes much more manageable using the Dante solution. Same with audio to multiple speaker sets or multiple devices for recording and playback. And if we peel the onion just a bit, go a little bit deeper in how this is all accomplished, really the first step is packetizing the audio data. And that's, under the covers what is happening with Dante solutions. And that data is being encapsulated into standard IP packets and transmitted on a standard Ethernet network. And really where those packets then are encapsulated and we're managing the header information and being able to decipher and decode that information with low latency latency on the networks. That's really where the advantage comes in, over just packetized audio. Being able to manage that audio and then set up routing from one to many devices on the network is really where the Dante solution becomes interoperable, across devices and across mediums, whether it's hardware or software. So if you're familiar with Audinate and the Dante solution, you may have heard of some of the hardware chips that we've manufactured for going on 15 years, over 15 years now, building up this product base and integration with manufacturers' products. So these chipsets get embedded into existing products that you may know of today. And we're expanding, certainly always expanding with more solutions for higher channel counts, solutions to access more widely available hardware like Linux and ARM processors, and solutions for audio and video coming into availability, and being implemented in devices already. As we look into software, and again, if you're familiar with Dante, you may have heard of some of these solutions. The Dante Virtual Sound Card is an application that runs on Mac and Windows and effectively acts as a sound card, like it's titled, to allow you to send audio or transmit audio to the Dante network, and similarly allow you to receive audio from the Dante network. Dante Via is another application that takes the concept of Dante Virtual Sound Card and being able to send and receive audio, but also gives you routing capabilities between your local applications. So being able to take audio from Zoom, for example, and route that to DAW for recording, or being able to take audio from a playback media player and sending that to multiple destinations, either on the same machine or other devices on the Dante network. And what we're really excited about is the Dante Application Library. That's taking the functionality of Dante software and providing that in an SDK that you can use to implement Dante into your applications. And we'll look at that in detail today. The Dante AV solutions are quickly being developed and expanded. So we've got a few offerings that are now in the market, and you may see those. There are cameras available from Bolin and Patton, and decoders and encoders. So these devices work on your existing Dante networks, and we're starting to see this convergence and excellent opportunities with audio and video on the same network. So certainly want to make sure everyone's aware that Dante is audio and video. And the vision, the roadmap here is to expand those solutions so that they are complementary. Everything that you've come to expect from Dante audio, you will be able to expect and more from Dante video and audio together. And all of the solutions come into the network get controlled or get managed through a series of applications. The Dante controller, which is to manage routing and subscriptions between devices, and Dante Domain Manager, which allows you to establish connections between different segments of your networks or different subnets in large implementations, and allows you to enforce access and control policies, and really allows you to take the audio video solution and really complete the offering and really turn it into a full IT type of solution, a fully managed solution. And from Audinate, the company, we're providing the engineering behind all of this technology, training with a really robust certification program that I strongly recommend, and an amazing support team that works with end users, integrators, manufacturers, developers like yourselves. So yeah, we certainly encourage everyone to learn more about Dante, and I invite you to look at the certification program as a great way to get up to speed. So with that, let's look a little bit more in detail about Dante and computers. And really, up to this point, we're all probably familiar with using USB and Bluetooth devices to connect to our hardware and software, which has been a viable solution, but certainly poses limitations, especially when compared to a networked audio solution. As you look into more professional applications and professional gear, we have more demanding requirements as opposed to a single point-to-point connection or a single device connecting to a single application. We've also developed several hardware components or devices that allow you to connect mobile devices or small analog channel counts. These are called Dante Avio devices, and these are used they actually have the Ultimo chip. So looking at our hardware devices or hardware solutions, and these devices are used to connect different formats, whether it's already digital like USB or Bluetooth in this case, or analog formats, converting to and from the Dante network. So it allows you to easily retrofit analog gear to your Dante network. We previously mentioned Dante Virtual Sound Card, and here I'll show you a screenshot and talk about some of the features. So one of the biggest advantages is that it's very simple and lean, and it performs a very specific purpose of transmitting and receiving Dante audio on the network. It appears as a sound card under ASIO or WDM or Core Audio on Mac, and it provides 4 milliseconds latency, which is critical if you're playing back audio or synchronizing audio across the network. Another software solution from Audinate is the Dante Via application. And this application provides the same functionality in terms of transmitting and receiving audio from the Dante network, and also allowing you the ability to transmit and route audio between applications on the local machine, as well as make those applications Dante enabled or Dante available, so to speak. So turning on Dante for an application makes that application then visible on the network. So you can subscribe or establish a connection from another device or another machine on your network. But as we look into these, there's a few similarities and a few differences, and ultimately there may be some limitations depending on your use case. The applications are specific. DVS is really highly tuned and tailored toward sending and receiving audio. Via is really tuned toward routing and flexibility, but there's trade-offs in both of those solutions. Furthermore, you can only run DVS or Via, and you can only run one at a time on a machine. So again, we get, in some cases, the feedback that we've received is, that could be a limitation in certain environments. So what if we could do all of those things with Dante and not even have to leave your application? And users could do all of this without having to ask administrators to install software like DVS or Via, in corporate environments or in large enterprise environments or educational systems, without requiring any special knowledge or any extra steps. All of those features can be made available with the Dante Application Library. Furthermore, you can run multiple instances. So every piece of software, and even multiple pieces of software, if you have a suite, for example, can incorporate Dante and allow transferring audio between those instances. Dante Application Library is delivered as a library, a C++ library, and we'll talk a little bit more about that later. And really, further than the technical details, we've talked about the hardware solutions and how we've grown the user base and Dante ecosystem already on the hardware side. We have over 3,000 products that have been brought to market, and using Dante really, and Dante Application Library can dramatically reduce any confusion or extra steps that users have to take. So for example, a conferencing system that can automatically identify Dante microphones and speakers in a conference room and make those connections really simplifies the experience for the user that is joining a conference call. They don't want to deal with making subscriptions and setting sample rates and doing technical bits. So yeah, a little bit more about the application library itself. It's available for Mac and Windows. It allows up to 64 by 64 channels per instance, and you can run multiple instances, so something to consider there. Currently supports 48 kilohertz sample rate, with soon adding 96 and 192. Minimum latency latency is 4 milliseconds, and that's again for that deterministic latency, which provides value in synchronizing sources and playback destinations. So it works with all of the existing hardware and software that's already in the market, and really comes in three parts. The instance API is used to create a Dante device on the network. Now, this is a virtual device. It's your application, or it's a component that you're running that appears like a Dante device on the network. And then the audio API is used to access those audio samples and put audio on the network or take audio off the network. And then further, really above and beyond what we've talked about with Dante Via and Virtual Sound Card, which exists today, the Connections API allows you to programmatically manage and maintain connections between your Dante instance, your DAL instance, and devices on the network. So in that example of a conferencing solution, you bring up the conferencing application, and the application can automatically detect Dante devices that are available and essentially pair those devices. And so managing and maintaining those connections. That's really an advantage over the existing software solutions or the Audinate software solutions of DVS and VIA. So as we said, it's a code library. It's delivered, it's C++, and we provide example code and documentation for anyone that wants to use the library. And it's licensed with an OEM or ISV access token. We can talk more about that model. We have different scenarios that we'd be happy to talk through in terms of how we make this available to end users. If it's something you want to embed in the product, if it's something you want to make the product Dante ready, and then have users really sign up for what they need in terms of channel count and requirements and features. And we certainly provide support to you as developers and independent software vendors. We want to make sure that you're building software that's successful in the market, and further our existing support in terms of marketing efforts, leveraging the existing user base and getting information about Dante ready products out to the market is something that we do already, and we would be happy to provide for any partners that are looking to develop Dante ready products. We've talked about some use cases already, so just to maybe highlight those or put some specific examples on the screen. We certainly see an opportunity and need for Dante specific productivity tools, or maybe more simply utilities, monitoring Dante audio and video on the network, or any sort of conversion or bridges to online services are certainly popular solutions that we've seen. And then, retrofitting existing media server and conferencing applications, and building into lecture and courtroom recording. Certainly a lot of opportunities and use cases where we've heard from customers and we've heard from developers that are building and interested in building more of these solutions with Dante ready capabilities. Some that are already in the market, we can share here. Zoom Rooms is a conferencing solution that incorporates Dante and automatically identifies speakers and microphones and makes connections. The IntelliMix Room software from Shure is effectively a DSP solution that allows you to combine multiple audio sources and provides various DSP functionality like noise cancellation or feedback suppression, those types of functions that you would expect in conferencing software. And Christie Digital they build projectors and they provide, alongside those projectors, a media server application called Pandora's Box. So they've built Dante Application Library directly into Pandora's Box so that their software is tightly integrated with the output devices that are their projectors, as well as any video screens, as well as audio devices for playback or microphones for capture. And they can control all of that in their application. So we've got some great feedback from the product manager at Christie Digital, Marcus Seppenfield, and really they've been able to take their application and integration to a new level, which really simplifies the user's experience. And for them, that's operators, that's somebody in a production environment under stress who just needs it to work. So we're really happy about that. We invite everyone to try the Dante Application Library. There's a free evaluation on the website. So if you go to audinate.com/DAL or scan this QR code, there is a registration, and then we'll provide an access token for you to use with the SDK, and that'll let you look at the example applications and also immediately embed the SDK into your application to really kind of see what the potential might be, and we'd be happy to discuss your use cases and any any potential uses that you may find. So I think that's everything. I'll go back to leave this up, but certainly open it up for questions.
Thank you so much, Alex. Yeah, really interesting talk. We have 2 questions so far, and I'll give a couple more minutes for other people to ask any questions. Looks like we have some more coming through as I'm speaking. So please ask any more questions in the chat. So first question is from Lori, who asks, can you say something about the Dante licensing model for small business hardware developers? Are you open to small manufacturers of Dante-enabled hardware?
Yes, and thank you, Lori. So historically, being a hardware company, Audinate is very much operated on a royalty type of model. So, we're certainly familiar and open to discuss that type of option. But as we expand and work more on software and embedding software, that gives us more opportunities to work on different types of models, whether that's a model where you build Dante into your application and then can turn over to Audinate the responsibility for licensing, or pass through that responsibility. So ultimately, we can work with you to get started with low or no barrier to entry, and then ultimately work with you so that there's not any so that the model is appropriate. It fits your business in the best that it can. We have multiple options, and really can even talk about how we could leverage our own marketing potential and user base, where we already sell software to end users. So there's a garden, so to speak, a market there already that we can talk about working together to bring products out.
Great. We have a question from Chris, our very own Chris Roberts. And somebody had answered this, but it'd be great to hear your take on it. Are there Dante specific routers that manage the QoS of Dante packets?
No, and we're really router agnostic. We're working on just general IP, so just standard networks. No required devices. There are recommendations that we can make about how you would configure quality of service and how you would set up your environment for the best performance, or really to meet your goals, whether that's performance or redundancy or a combination of everything. But yeah, no specific networking requirements, and that's really one of the main differentiators in Dante as a whole.
Great. And there are a couple questions from Tugrel. What kind of protocol does Dante use at the IP layer? A similar type of RTP, like iPhone, or a new protocol that has been developed? And does it use compression algorithms for numerous channels?
No compression. The audio is PCM. So the no compression or effects on the audio. I guess the technology itself is, or the protocol is really the proprietary part. The audio packets aren't anything magic. It's just PCM audio sliced up. It's the headers that are really the special part, and being able to decipher those headers and use that information to route the audio quickly is really what makes the Dante solution unique, and really, it's effectively our own protocol at that point. But we don't like to call it a protocol; it's a solution, because we have the devices that know what to do with that audio with those packets.
Okay. And there's another question from Tugrel. Are there any restrictions on switches and routers used between Dante devices? For example, how many routers can be in between Dante devices?
No hard and fast restrictions. What we've found is every switch that you add or router that you add generally adds about 1 millisecond of latency, and or at minimum, I guess is what we would say, depending on what it's doing and the load that it has. But adding more network hops increases the latency, but otherwise does not affect performance or functionality. And there's no specific requirements. Lots of general off the shelf routers and switches work. Certainly standard enterprise scale routers and switches work. And we have some documentation on our website for specific models, Cisco's, for example, and what you would configure, what we would recommend.
Great. George asks, is the FPGA solution targeted mostly at video, or does audio play into it as well?
So yeah, the Dante AV chips do carry audio. I believe it's 8 channels. I would have to confirm that. So audio and video is the intent, and they will be, that'll give you the ability to synchronize that audio and video, which we realize is important. You have to, in most cases, delay the audio to match up with your video.
Okay. And we have a question from Bitcher. Now moving Dante to the software realm for applications. Is there anything that you're working on that is related to using it in the cloud?
I don't know if I'm officially allowed to talk about it, but maybe that gives you some
clues.
Yeah, something to look forward to. We recognize the prevalence of the cloud and the benefits of those cloud-based solutions. And really what I'm seeing, I can tell you, a lot of customers that are building cloud solutions are talking to us about building bridges, Dante bridges, to take audio from a Dante network to a cloud production service, for example. So what we might imagine is what is a large or multiple unit production truck on site today may shrink down, and some of that gets distributed in different ways. The Olympics, as an example, having commentators not necessarily on site is something that we see more and more. So the Dante Application Library becomes a critical component to get the audio on and off the Dante network, and then into your format and into your cloud and into your solution. We recognize that, and we recognize that we can help facilitate that as well. So yeah, certainly stay tuned.
Great. Steve Dwyer, hi Steve, asks, have you created Wireshark definitions for these headers to aid debugging network traffic?
I'm not aware of those, but I can certainly check with the engineering team. I would, just want to make sure that we're not exposing any proprietary details in those, but yeah, it sounds like something reasonable.
Okay. And I think that, this has been answered already, but Malcolm asks, is there anything stopping him from using this in a virtual machine? So virtual machine, I'm thinking in the cloud, or yeah, are we talking, or maybe he's thinking something.
Yeah, if you're familiar with the existing Dante software licensing model, where it's a node locked license, and that's where we start by default in our discussions about Dante Application Library. When we get into virtual machines, that could potentially pose a problem. So we would want to know a little bit more about how you're using the virtual machine. We recognize that there's value in even reducing a hardware footprint, running multiple VMs on one piece of hardware. That's different than scaling with VMs to accommodate load. So we want to make sure the licensing is commensurate with the usage. So by default, we start with a node lock license, but we are flexible, and we do understand that in a virtual environment, we don't want to have to make you pay for a license every time you reboot your virtual machine and it looks slightly different, even though it's the same machine. Or we don't want to be taken advantage of if you're scaling up and you buy one license and run 10. So we have to balance that, but we're happy to talk through it.
Great. That looks like all the questions that we have for now. Thank you very much, Alex. Looks like a great response. And
thanks for having us.
Fantastic. Cool. So next, we are going to jump into a brand new special monthly feature that Rachel and I have named DSP Corner. So one thing that Rachel and I were discussing was about how it would be great to have something where we could teach some DSP fundamentals and talk and help talk about some things that aren't talked about very often within audio programming. And Rachel's happy to give this monthly feature. And just to tell you a little bit about Rachel, Rachel and I have known each other for a couple of years now. And she's just graduated with a master's in digital audio engineering from the University of West London. And today she's going to talk a little bit about mathematical notation. So
yes.
Take it away, Rachel.
Thank you, Josh. I'm just going to get my presentation up and running.
While Rachel's getting her presentation running, just one more question for you, Alex, before we start. Stein asks, is there anything about pricing for including the library on 1,000 synth units on some type of Linux system? So if they wanted to include Dante on a Linux system on a synth.
Yeah, we have a solution called Dante Embedded Platform that I would suggest we could talk about in more detail. That's available for Linux. And then, yeah, as far as licensing, you know, I guess generally there's two components. There's a subscription for the technology and then a per instance activation that we would talk about. So yeah, just, you know, with those volumes, we would certainly want to talk to you specifically about your use case. And yeah, I think Dante Embedded Platform, or DEP, would be something to look into on the website or talk to us about.
Fantastic. Okay, great. So yes, Rachel, thank you very much. She's going to give a talk about mathematical notation. And yeah, I'm very excited to see this talk. I need a lot of help on this. And
just an introduction this week, but we'll ramp it up
Fantastic.
As we go. Yeah, all good. So thanks for the introduction, Josh. Very warm welcome to the first episode of my new series, DSP Corner. So I came up with the concept of DSP Corner because I've just recently finished my master's, as Josh said, in digital audio engineering, and a large portion of my master's focused on engineering mathematics and specifically DSP mathematics. And coming from a music tech background, I found the resources and textbooks that taught DSP mathematics quite inaccessible to jump into as a new student to this area. So I thought it'd be nice to maybe come up with a series where there's some nice little diagrams and explanations that could lower the barrier to entry for DSP and provide some nice introductions to those concepts. The room I'm in has a refrigerator in, and it's just started like a low-level hum. So I hope that's not going to interfere with the video. Maybe next month we can write a comb filter to remove the hum. Only joking. So let's get started. So first off, I'm just going to give a quick introduction to signals, just make sure we're on the same page regarding continuous time and discrete signals and their notation. So an analog or continuous time signal is a physical quantity that varies in time. In our case, when you're talking about sound, a signal is a function of air pressure over time, time being the continuous medium. When we sample or digitize a signal, we are left with the independent variable n, meaning that now we have only integer points n to represent the amplitudes of our original signal. You can think of this as moving from infinite precision time to finite precision samples. In terms of mathematical notation, you can see in the table at the top of the slide that continuous time, sometimes called analog, is notated with round brackets and the independent variable t. And you can see in discrete time or digital that we use these square brackets and the independent variable n. At the bottom of the screen, I've got plots of a continuous time signal and a discrete time signal. The continuous time signal on the left shows a smooth, unbroken sine wave, whilst the discrete time signal on the right shows a sine wave that only has amplitude values for integer samples n. I just noticed that whoever made these plots did not label the axes. I would invite you to always label the axes because this is very important in terms of viewers knowing what the quantities are on either of your axes. But for these ones, we would have time as the x-axis on the left graph and samples n as the x-axis on the right graph. Sinusoidal signals are incredibly important when it comes to audio signal processing. We'll see later on in the series that this is because any audio signal can be decomposed into a combination of sinusoidal elements, each with their own frequency and phase information. Let's have a look at some of the measurable properties of sinusoids. The first property I'd like to talk about is period. A signal is periodic if it repeats an identical pattern after each period t from -infinity to +infinity. The period is the shortest distance between identical points. If you can find no period t larger than 0 at which the signal repeats itself, then this is a non-periodic signal. We can see for the sinusoids that when looking at the cosine, at the origin, the value is 1. And we see the next time the value is 1 for the cosine here in blue, the period is 2 pi. So the distance at which it repeats itself is 2 pi. And we can see the same thing happen for the sinusoid that starts at 0, and at 2 pi, we have a value of 0. What is the mathematical notation for periodicity? We say a signal is periodic if x of t plus capital T is equal to x of t. So that is to say that if we take a point on our signal x of t and add to it the period capital T, then we will be left with the same value like we just saw. So we've determined that sinusoids are periodic in 2 pi. So we can say that x of t plus 2 pi is equal to x of t. We can also say that sinusoids are 2 pi periodic. The next quantity I'd like to talk about is phase shift. Phase shift describes how much a signal is shifted from the origin. We often express phase shift in terms of the cosine. We'll see why this is done a little bit more when we start looking at rotating phases and the unit circle later on in the series. But for now, we'll measure the phase shift from the cosine because it starts at 1 at the origin. So if we look at the sinusoid in relation to the cosine, we can see that the peak happens approximately pi over 2 distance later. So how can we describe the relationship between sine and cosine? We can say that sine is equal to cosine shifted by minus pi over 2. Now you might be thinking, why are we saying minus pi over 2? It looks like that signal, the red signal, is shifted in a forward direction. So shouldn't it be plus pi over 2? Well, actually, in signal processing, this is what's called a delay, because that signal will be reached later than the blue signal. And if you move a signal to the left, that's called an advance. So in this case, we've moved the signal to the right, or the sine is shifted to the right of the cosine. So we can call it a delay. That's why it's minus pi over 2. If we want to express the phase shift in terms of sine, we could say that cosine is equal to sine plus pi over 2. The final quantity I'll mention is amplitude. Amplitude is a scaling factor, which in reality translates to a perceptual loudness of a signal. What does the A represent in amplitude? A signal with amplitude A oscillates between plus A and minus A. So we can see by looking at our sinusoids that they oscillate between +1 and -1, meaning that our amplitude is 1. Another quantity we haven't yet mentioned is frequency. Period and frequency, measured in hertz or cycles per second, have an inverse relationship. The inverse relationship is such that frequency is equal to 1 over the period, and period is equal to 1 over the frequency. In mathematical notation, we represent the frequency with a lowercase f. In mathematical notation, as we saw before, we represent the period with an uppercase T. I'll mention at this point that generally in signal processing, or especially audio signal processing, you will reserve lowercase letters for the time domain, which is what we're looking at right now, and uppercase letters for the frequency domain, which we're going to be looking at later on in the series. The period being capital T is just an exception to this rule that we're going to have to deal with, I'm afraid. But yeah, usually it will be a lowercase for time domain and uppercase for frequency domain. As you can see at the bottom of this page, we've got two sinusoids. The bottom sinusoid is double the frequency of the top sinusoid. And I wanted to show the relationship between frequency and period. So we can see that the sinusoid that is double the frequency has half the period. And we can see that the sinusoid that has half the frequency has double the period. So we can say that doubling in frequency causes a halving in period, and a halving in frequency causes a doubling in period, showing the inverse relationship between the two. Here we are looking at the general mathematical formula for sinusoidal signals. Sinusoids are characterized by 3 parameters. These are amplitude, frequency, and phase shift. I've given the formulas for both continuous and discrete time sinusoids. The only real difference is in the notation is the brackets and the independent variable. You can see that for the continuous time sinusoid at the top, we have the round brackets and we have the independent variable t denoting time. We can also see in the body of the cosine function the independent variable t. Down here we can see that x of n has square brackets denoting a discrete time signal. And again, we see the discrete time independent variable n in the body of the cosine. We're introduced to a new notation here for the frequency. That's because this frequency is expressed in angular frequency. We use the Greek letter omega to represent this, or omega 0. So angular frequency is in radians per second rather than cycles per second. At the top of this page, I've provided some conversions between radian frequency and regular frequency. And we can see that if we times regular frequency by 2 pi, we're given radian frequency. And on the right side of the screen here, I've shown the equivalence between using omega 0 and 2 pi f, just to show that on both sides, those two are completely equivalent. I'd like to bring your attention to a common way of notating signals whilst introducing 2 types of useful signals in DSP. On the left-hand side of the equation is the notation of the signal we want to express. In this case, we use the Greek letter delta to inform the reader that this is a Dirac delta function, or more well known by audio folks, this will be called an impulse function. On the right side of the equation, we're given the value of the signal at any value of n. So it says here that the signal is equal to 1 when n is equal to 0. as we can see in the diagram on the right here. And the signal is equal to n. The signal is equal to 0, sorry, when n is not equal to 0. So for all other values of n, the signal is equal to 0. Below that, we have the unit step function. That's denoted with the notation u of n. And we can see for the unit step function that it has a value of 1 for n larger than or equal to 0, and a value of 0 for n smaller than 0. And you can see that in the diagram on the right here. So called a step function because of the step up to 1, sorry, at the origin. Before we finish, I'd like to give a quick introduction to systems. Since the series is loosely based on a signals and systems course, it's important that we also look into the notation of systems. A system is a process that produces an output signal in response to an input signal. A system is often denoted as a rectangular box like we see at the top here. It has some input, x of n, and some output, y of n. On the box here, I've written capital H. This is something that you'll commonly see. When I said H was often used for the frequency domain, capital H is what we use to denote the frequency response commonly, and we'll see why we might label a system with capital H further down the line. Before we get into that, and to finish off today, I'd like to introduce the idea of linear time invariant systems. This is something you'll come across in DSP a lot. And today I'm just going to go over what the properties are of a linear system. So what needs to be in place for us to call a system linear. And then next time we'll have a look at time invariance. So the first property that we need to have for a system to be called linear is homogeneity. A system is said to be homogeneous if an amplitude change in the input produces an identical amplitude change in the output. That is, if an input signal x of n produces an output y of n, then an input signal scaled by some scaling factor k should produce an output y of n scaled by an identical factor k. The second property we have to have for linearity is additivity. A system is said to be additive if, when two or more input signals are added, they pass through the system without interfering with each other. That is, if an input signal x1 of n produces an output signal y1 of n, and an input signal x2 of n produces an output signal y2 of n. If we add x1 of n with x2 of n and feed it as an input into a system, we want to receive the output y1 of n plus y2 of n. This might be a lot to take in at first if you're new to this, but just remember this is about preservation. We want to preserve the scaling that we do to x of n in the output, and we want to preserve the addition of x1 of n and x2 of n in the output. Thanks so much for joining me for the first episode of DSP Corner. Yeah, I'd like to continue the conversation over in the Discord channel. If you haven't joined already, that's over at theaudioprogrammer.com/Discord. And yeah, catch you all over there soon.
Thank you very much, Rachel. I've learned a lot there. And
Great.
yeah, this is really fantastic. And I'm really proud. I'm really proud to have this as part of our monthly meetup. I think a lot of people are going to find this very useful, not only in the meetup as we do them, but also when we cut the videos down afterwards and have them as just digestible little chunks of lessons in their own playlist on the channel. So thank you very much, Rachel. And would you like to introduce our next speaker?
Yes.
Great.
So I'm going to take off my guest hat put back on my host hat. So next up, we have Chris Roberts. Chris is a software engineer with around 36 years of programming experience under his belt, mainly for audio-related companies. Chris has one of the most impressive LinkedIn experience sections I think I've ever seen. So you're really in for a treat today. And Chris is going to be talking to us about value tree wrappers for juice-specific value trees. Everyone give a warm welcome to Chris.
Thank you, Rachel. Thank you. Yeah, so I started, I've been using Juice for probably 15 years now, but I didn't dabble in value trees until about 5 years ago. And if you've not watched Dave Rowland's ADC talk on value trees, I think that's the best education videos there are, giving you a good, nice, round understanding of what's possible with them. After I'd been using them for a while, I started to think about things like having to write value tree code every place that I needed to access that information. And I also started to give consideration to implementing the entire data model set for applications with value trees. To make them easier to use, I came up with this idea of what I'm calling a wrapper, but it's really a domain-specific class for something that is using value trees under the hood to do its work. And then you get, of course, the value tree benefit without having to think about value trees as the user of that class. One of the ones I like to talk about as an easy example is the idea in an audio application of a transport. And historically speaking, right, we'd have code hooked up where the state of the transport is passed through some callback maybe, or some parameter that you poll to get the information from. And so in some applications I've written a transport value tree wrapper class. If you hand it the value tree that is for that thing, you can communicate through the transport through the setters and the getters, and you can get the callbacks through callbacks just like with value trees. So the idea again is you create a domain or context specific class that's got a series of setters and getters for accessing the values inside the value tree, which also gives you type safety again, because with value trees you kind of lose your type safety because a value tree contains a var, a juice var, and a juice var can contain a variety of types of information. And so this gives you your type safety. Also gives you the ability to hook in constraints and things like that to those specific parameters. And then just like with the juice button classes, now you have these on callback type things. The value tree wrappers use that same methodology. So on state changed might be, or in transport state changed might be the callback you have in the transport wrapper. And so you can just sign up for that to know if the transport state's changed. The extension for me that I've gone with this now is that I'm writing applications that have two main value trees. One is the persistent value tree, which is attached to another class I have called the value tree file class. If you hand your value tree to this file class, it monitors any changes to the value tree, and then will do a deferred write out to a backing file for that value tree. So what makes this easy is then again, if you have a place in your application that you have some information that you want to be stored persistently with your application, simply by adding your value tree to the persistent value tree, you have to do no more work, and it will be saved in your properties file and restored from the properties file when your app starts. Then of course the other one is the runtime value tree, which is all the data that changes at runtime and doesn't get stored. So the format of the applications now, instead of passing pointers around between objects, pretty much everybody's initializer gets the top level of the persistent tree and the top level of the runtime tree. And that's just a common practice in this code. Then within the code that receives those two value trees, you might then take that value tree and hand it off to the wrapper that you want to get the object for. So again, system started up. Some piece of audio code has created the transport value tree on the runtime main value tree. And so in some other place of code, you simply hand that runtime value tree into the transport wrapper code, and it will find the child and give you access to that on the main tree. And as implied here, I've also started using it again to even decouple code, where instead of having the play button code actually call a function that starts playback or stops playback, it simply uses the value tree to communicate that. And so again, you've decoupled the code through passing this information through the value tree system, and it's easy to access some other piece of information without having to think about, well, how do I get to that class that has that piece of data that's other, someplace else. The other piece that I've added to this, because I've been using this for talking to hardware devices, is the value tree wrapper base class has this idea of being able to turn on and off the feature of a value tree, which is to not do any callbacks if you call a setter and you're setting the same data. You want to be able to have it go through, even if it is the same data, if you're sometimes working with hardware, because a piece of hardware has been plugged in, you don't actually know the state of that hardware. So when you're sending the data to it, you actually want it to send all of the data. So you have the ability to tell the value tree wrapper you're using that you don't want to filter the non-change data, and then you can do all your operations and know that all the callbacks happen even when the data hasn't changed, and then you can turn it off. I've actually created, much like the scoped lock class and things like that in Juice, I've created a scoped object that also will allow you to turn this off or turn it on for a given context, and then when you leave scope, it reverts it back to what it was before. Yeah. I think that, it's a relatively simple idea. And some people who I've explained it to have talked about there's a lot of boilerplate up front. But the trick is when you hear from the people who are using it now, and they're like, oh my God, that was so simple. I just had to, use the wrapper to wrap the thing and sign up for the callback, and I'm done, and it all works. So yeah, that's that.
Nice. And is there a place where anybody would be able to see an example of how this will be used live in the wild?
I have not put it out onto any public GitHub stuff yet, but I'm planning on it. Okay. And so yeah, so I'll include some examples with it within that.
Okay. Do you know your GitHub URL off the top of your head by chance?
I think I'm CPR 2323.
CPR 2323. Okay, yes. Cool. So just so I can put that in the video description, and yep. I will put it here in the chat as well. Yep. Yes, thank you very much, Chris. It's very enlightening, and we're looking forward to seeing some example code so we can actually so we can see how it works in the wild, and I think it'll be very valuable for people. As you mentioned, Dave Rowland's talk on value trees is probably one of the iconic audio programming talks in all of ADC history or audio programming history. So it's essential watching for anybody that's interested in Juice parameters and value trees. The audio processor value tree state is related to that as well. And we appreciate you coming in. Cool.
Yeah, and I look forward to doing it as well, to start getting some feedback, because like a lot of things, the longer you use them, right, the more mature the code can get, and there might be some other ideas that could be, other people would be aware of when they start playing with it. So yeah.
Absolutely. Great. So with that, just a few little announcements before we sign off. First of all, I'd like to thank Alex, Rachel, and Chris for their talks. Really great having the pleasure of being in the company of you three, and very lucky to have this meetup happening each month. And speaking of our monthly meetup, we're going to confuse people and tell people that our next meetup is actually going to be a hybrid meetup. So I'm proud to announce that our next meetup will be both in person and online at the same time. And we will be live from London. And the date is going to be on Wednesday, the 11th of May. And we will have some very special speakers, including Rachel. Rachel will be speaking for the meetup, and we have some other ones that I don't want to announce just yet, but I will create I will have a flyer created, and we'll be able to announce probably later on this week, as well as venue and time. So we're very excited for that. Also, as Rachel mentioned, if you happen to have any questions regarding presentation on DSP Corner, please be sure to join us in our developer community on Discord. And the link for that is theaudioprogrammer.com/Discord. Also, if you'd like to submit a proposal for giving a talk here at the Audio Programmer Meetup, you can do so. And the link for that is in the description below, or if you'd like to write it down really quickly, it's theaudioprogrammer.com/meetups with an S at the end. Is there anything that I've forgotten, Rachel?
I don't think so. Just to say, I'm really excited to be taking the meetup live next month and getting to see some faces in real life.
That's it. Yeah. Also want to give a big thanks to our sponsors as well. One more time, Sonox, Juice, and Focusrite. Thank you very much for sponsoring the Audio Programmer Meetup. And maybe we could tell a little bit about your meetup next month. Rachel, would you want to announce that online, or do you want to keep it?
Sure. I can say a bit. Now that we finally have a venue, been looking for a while. So my friend Harriet and I are starting a C++ study group called Dynamic Cast. And the study group invites specifically underrepresented groups in C++ world to attend. So that's women, LGBTQIA+, or ethnic minority people to attend our meetup. It's going to be in London, and it's going to be the first event is going to be on the 9th of May, which is a Monday, and it will be 7 to 9 p.m. So if you are interested, or you know anyone that could be interested in attending our study group, it's more of a peer-to-peer study group than us particularly teaching C++. Just a safe space where everyone can share ideas about what they've learned, share barriers to entry to the industry, where we can talk about job opportunities as well and put them forward to people. Please do get in contact with me either via the Discord or through LinkedIn under Rachel Locke.
Yeah. We're on Twitter, Madam Modular.
Yeah.
Yeah.
Madam Modular on Twitter as well.
Yeah. Are you Rachel Locke on Discord? Is that where people would find you there?
I think I am, yes.
Okay.
I believe
Fantastic.
so.
Yeah.
Well, really looking forward to getting started with that.
Yeah. Great. So be sure to check out the dynamic, and the name of the group is called Dynamic Cast.
Yes.
9th of May. And Rachel can give you more details. So with that, I think it's a good time for us to sign off. Thank you once again to everybody who tuned in, and to continue the conversation, please join us on Discord. We want to talk and continue this interaction, and this video will be made live to view afterwards. So we hope that it's very helpful for you. And with that, we will sign off and we will see you next month live from London.
Thanks, everyone.
Thank you.
All right. Thank you, everybody.